assessment. Let's take a look at it. Our end of Unit 5 assessment review. Number 1, which two-dimensional figure is always formed when a plane intersects a right cylinder perpendicular to its base? So, cylinder, I could probably draw this better, but okay, let me see if I can. My cylinder up, okay, and if I were to cut this and then open it up, what shape would I get? And it would be a rectangle, okay, perpendicular to the base. The base is a circle. Well, it's the two circles, right? Our bases, and perpendicular means it's going to be forming a right angle with the base. Okay. Number 2, which object is formed when the right triangle RST shown below is rotated around leg RS? So we have this altitude or leg RS, okay, right here. And if we were to spin this around, that's my dog getting frustrated. If we were to spin this around, right? My drawing skills. Let me see if I can. We would get a shape that looks a lot like this. Right? And this is a cone. Right? All I did was take the bottom and I swung it around and then I connected the top. Okay. The base of a pyramid is a rectangle with a width of 4.6 centimeters, a length of 9 centimeters, and a length of 9 centimeters. What is the height in centimeters of the pyramid if its volume is 82.8 cubic centimeters? Okay, so V for a pyramid, right, equals 1/3 base times height. Height. Okay, so we have a pyramid. Okay, rectangle pyramid. Let me see if I can do this better. Right? I feel like there's probably a better way to draw that. Okay, V equals 1/3 base times height. Okay, this is a 3. And so we have a rectangle with a width of 4.6 centimeters and a length of 9 centimeters. And then it has a height of, oh, we're looking for the height. What is the height in centimeters of the pyramid? Okay, so our volume is 82.8. You're being very destructive. Okay, and that equals 1/3. right? 4.6 times 9 times h. Okay, so let me see if I could just move this over, and I move this over, move that over. Okay, and this 4.6, right, times 9 times h. So, okay, let me pull out, which I should have taken out already. TI-84. Okay, so that way you can see what I'm doing on the calculator. So there's a couple ways to solve this equation. One way, of course, is to solve for h the way we usually do with all of the numbers, and then there's another way to just use the calculator altogether. Personally, I want to show you both if I can. I am struggling with making this window a little bit easier to see the calculator. Okay, so we have, and I'm going to use my fraction because I like it better, 1/3 times 4.6 times 9. Okay, so that equals 13.8. Okay, so we have 2.8 equals 13.8 h. Now we can see that this is the coefficient of h, so we're going to divide it out. 0.8 both sides, 13.8. Okay, so we have 82.8 divided by 1 second, 13.8. Okay, and our answer is 6, and we have that answer right here. Now I want to also show you on the calculator. Okay, you can go to math and go to down all the way to numeric solver, and we had 82.8 on one side of the equation, and on the other side we had well, I'm going to go from the whole thing so you can see alpha y equals 1/3, right, times 4.6 if I'm not mistaken, 0.6, okay, and times 9, right, and we had an h, which I'm going to put as an x. Okay, that, hit solve, and x equals 6. Okay, so that's one way you can use numeric solver to solve for your missing variable. I put it in as x because it's easier to use the variable button here. Yeah, so that's one way to solve it if you don't know how to solve the equation, although I hope by now you guys have an idea of how to solve an equation. Okay, so our answer is 6 there. You know, I can see the appeal to actually pay for the TI-84. I think that I'm going to do that next time. Okay, so let's see if I can move this all out of my way. Just so that I can read next thing. Okay. Number 4, a sphere is inscribed inside a cube with edges of 6 centimeters in cubic centimeters. 6 centimeters in cubic centimeters. What is the volume of the sphere in terms of pi? So that means I'm not going to multiply it times pi. I'm going to leave the pi by itself right there where it looks 12 times pi. So I'm not going to multiply 12 times 3.14. I'm just going to put the pi symbol. Okay, it means the same thing. It just wants it in terms of pi here. So we have a sphere that is inscribed in a cube with an edge of, 6 centimeters. We've actually seen a similar problem, and okay. All right, so this sphere is in this box, right? And the edge is 6 centimeters, so we know that the diameter, excuse my drawing, but the diameter is 6 centimeters, okay? So our formula for the volume of a cube is 4 over 3 pi r cubed, okay? So we have r is going to be 3, right? So we have 4 over 3 pi, right, times 3 cubed. Everything's moving. Okay. Then we have 4 over 3, okay, pi 27. 3 cubed is 27. 3 times 3 is 9 times 3 is 27. Then 3 goes into 27, right? 9 times. So we end up with 4 pi times 9. Okay. Hope you see how I got that. I divided it out and I ended up with 4 pi, and this becomes 9 over here. Okay, and it's 36 pi. Okay, now once you get up to here, right, if you're not sure how to do the math with the fractions and the crossing out, okay, in your calculator, you can do, just close all of that, right, clear, so you don't quit. All right, you can do 4 over 3, okay, and then 3. This sign is for your exponent, this caret or arrow up, right? I like to put it on the outside, cubed, right? And you get 36, and the pi is still there, so it's 36 pi. Okay, so let's take a look at number 5. Okay, a cone. Let's see. I see, this is not moving with it. Okay, a cone has a height of 8 inches and a volume of 75.4 cubic inches. What is the diameter of the cone to the nearest inch? So, a cone, the formula for the volume of a cone, right, is 1/3 base times height, right? And our base of a cone is a circle, so it's 1/3 pi r squared times the height. Okay, and we see that the height is 8 inches, and they give us, right, the volume. So we know this is volume, 75.4 equals 1/3 pi r squared times 8. Okay, now we need to find the diameter. In order to find the diameter, we have to find the radius. So if you want, you can do the math. Of course, you're more than welcome to. Remember, you could also use the calculator. Math, right? Numeric solver. And I'm going to clear this out. And I'm going to clear, well, I want to clear the whole thing, but I don't know why it's not letting me. Let me see what happens. Just messing around with it a little. I'm going to go to numeric solver, and my first equation is the volume side, so that's 74.4. There has to be a better way to deal with this calculator. So 74.4, okay, on one side of the equal sign, and then on the other side, alpha y equals, to get my fraction, and I have 1/3, right, times pi, right, times x squared, not that one, times x squared, right, and times, the height was what? 8. Okay, times 8. Okay, solve, and I have 2.980, so to the diameter, so okay, the radius is 2.980, so what I'm going to do is 2.980. I'm going to put that, 2.98 times 2, okay, 5.96 to the nearest inch is going to be 6, right? So, yes, 5.96 is going to be, right, to the nearest inch is going to be 6. So, diameter equals 6. Now, let me show you what I did in actual math and not just the calculator usage. But I just think it's awesome to be able to use the calculator and quickly solve problems. But So we have 75.4 equals 1/3, right, base height. 75, well, I'm not going to rewrite the height out again. So we have 1/3 base, right, and the height is 8. Okay, so we have 75.4 equals 8/3 B. Okay, let me move this down, and I cannot. Just want to make it easier to see. Now, to find B, right, well, I shouldn't have left it as B. I'm going to make that R squared because it's pi R squared is B. So I'm actually going to just make it pi R squared. Okay? So this B here is pi R squared. I think it's easier if you see it all. Okay, we still have 8/3 pi R squared. Okay, so I want to get rid of this. And how am I going to do that? I am going to, right, multiply by the reciprocal, which is 3/8 pi, right? I'm going to multiply both sides by the reciprocal. 3/8 pi. Okay. Now 8 pi gets crossed out here, and so does the 3. Okay. And we end up, remember this is a pi symbol. Just clear it up a little bit. So annoying to deal with this thing. Okay. 3/8 pi. Okay. Alright. There's no negative thing there. It's just parentheses. Okay. So, right. I'm actually going to erase this out because it's crossed out anyway and I need the space. Right? And that equals R squared. Okay. So, honestly, in the calculator, you could really just put this all in like that to find R. So, in your calculator, you can put your square root sign, and then we have 3/8 pi, and I think that you should definitely use the fraction and not like a slash, because the slash really gets the calculator confused too, and it multiplies things out differently. It's not really confused, it's just the order of operations is being done. Okay. So from there we had what, 75.5? Oh, 75.4. Okay. So times 75.4, and notice it's all under the square root sign. Enter. We have 3, okay, 3.0, which is about similar to what we came up with, right? 2.98 would round, you would still get the same number rounding, right? So the radius is 3 times 2, and we have a diameter of 6, okay? the other one we came up with, the calculator did solving the equation, so it gave us 2.98, but I get R as 3.0. I wonder why it did that. Make sure everything is in right. Oh, that's why it did that. I have 74.4 and it should be 75.4. Okay, there was a mistake there. So solve, and x is 3, so your answer should be 3. 3 for the radius, and the diameter itself is 6 because the diameter is twice the radius. Okay, let's take a look at number 6. What is the volume of a hemisphere that has a diameter of 12.6 centimeters to the nearest tenth of a cubic centimeter? So, the formula for hemisphere is 2 over 3, right? Pi r cubed. Okay, what is the volume of a hemisphere that has a diameter of, okay, so 12.6 divided by 2. So let's just write it out. We're finding the diameter, so 3. We're finding the volume, pi, and now we have 12.6 over 2 cubed. So just want to clean it up a little so you can see what I wrote. And this is 12.6 over 2. Okay, so go to the calculator. I am going to put alpha y equals, enter, and 2 over 3. Okay, and times pi, right, times alpha y equals, right, the diameter was, the diameter is 12.6, so 12.6 divided by 2, okay, and we have, I'm going to put the exponent using this arrow key, or caret key, right, and put it cubed and hit enter, and I get 523.697, and 540, it should be 23, right? 523.7, okay, to the nearest tenth is 0.7, so that is your answer. So, let's take a look at number 7. The square pyramid paperweight is made of cedar wood. Each side of the base measures 11 centimeters and the height of the pyramid is 15 centimeters. If the density of maple I see that this should be cedar. So this should be cedar. Okay. If the density of cedar is 0.59 grams per cubic centimeter, what is the mass of the block to the nearest tenth of a gram? Okay. So we have a base. It's a square pyramid. So, making it as square as I can. I'm really... Drawing is not that fun. Let me see. Okay, so we have 11 centimeters for each side, right? And we have a height of, so the formula for volume, or for density, well, formula for density is mass over volume. And, over volume, sorry, not multiplied. It's mass over volume. Okay, so we're looking for the mass. Okay, now we want to multiply the density by the volume to get the mass, right? In order to do that, we need to have the volume. So we have a formula of 1/3 base times height, which equals 1/3 11 squared times 15. Okay, now this is all being multiplied, right? So you are more than welcome to multiply everything out, right? And then have like numbers that you put there, but I'm just gonna put 59.59, right? Grams per cubic centimeter. Okay, is equal to, let me see if I can move some stuff around. This is a G, and it's equal to 1/3 11 square, not equals, well, yeah, well, not equals there, hold on, equals mass, sorry, equals mass over 1/3 11 squared times 15, and that's going to be in cubic centimeters, right? Which is going to get crossed out when you bring them over. So you end up multiplying. All right, let me erase some of this. Right, you end up honestly, well, no, I don't want to go too fast for you guys because I know, right? 0.59 grams over cm3 to the third, right, times 1/3 11 squared times 15 cm3, well, cubed. Okay, and that equals the mass. Now, fix this G so you can see that it's grams. And this is a 5. This is really hard to make look right, where you can see what I'm talking about. This is grams. Hi, hi, hi. And this is a 5. And this is a decimal. And this decimal, not a... Okay. So, you see that I'm multiplying this times this, right? And this is on the bottom, this is on the top, so it gets crossed out. Now, in the calculator, I'm going to do, right? Let me see. Answer key. I'm gonna do in the calculator 0.59 times, and alpha y equals a fraction 1 over 3, right, times 11 squared times right, let me look at what we did here, times 15. Okay, and I use the fraction because if you don't, it's just, yeah, you should use it as you would see it. And I get 356.95. 356.95 right here. Thought it was going to be easier to use this application, but I'm not sure about that. Okay, so let's take a look at number 8. Okay, okay, a jewelry company makes copper heart pendants. Each heart uses 0.75 inches, and that should be cubed, of copper, and there is 0.323 pounds of copper per cubic inch. If copper costs $3.68 per pound, what is the total cost of 24 copper hearts? So we want 24 copper hearts, okay? And this is the cost per pound. And we also know that each heart, right, has a volume. This is volume because it's 0.75, and then it's inches cubed. That's how I know it's volume. It's inches cubed, okay? And there is 0.323 pounds of copper per cubic inch. Okay, and I don't need to convert units here, but I see that this is the density because it's per, right, pounds, right, mass per volume. Cubic inches has to do with volume. So we have 0.323 equals mass over 0.75, and this is pounds per inches cubed, and this is inches cubed. Okay, and so we're going to cross these out because I'm going to multiply this on both sides. Right, 0.75 inches. 0.75. Let me just go back so you see what I did, right? Before I even cross it out. I mean, I know I'm crossing it out, but I'm going to multiply both sides by 0.75 inches. cubed. Okay. It's really hard to write on here, so I actually am getting to the point where I just want to write 0.75 inches cubed is what I'm going to multiply this by. No, go. Go. Inside. My dog is eating tissues and she's not allowed to. Okay. So, good girl. Okay. So I'm multiplying both sides by 0.75. I'm just gonna bring that here so it looks like I'm multiplying it. There you go. Now I'm gonna cross this out. And my mass is, I'm gonna also cross this out, and then I'm gonna multiply that. So I have a calculator, and I have 0.75 times 0.323. Okay, and that gives me 0.24. Let me just do it here. I'm going to just use Desmos. 0.75 times 0.323. Okay, and that's the number we got is 0.24225. Okay, so that's how much it is. That's how much mass each copper pendant is. Okay, so now that we have the mass for each one, I'm going to actually make myself have some space here. So each one is 0.24225. 0.24. Again, not dealing. 0.24225. Okay, that's the mass for each pendant, right? And each pounds, right? And each pendant the copper, right? This is each pendant, and we want 24 pendants, and this is the cost per pound. If copper costs this per pound, and we know each pendant's this amount of pounds, right? What is the total cost for 24 pendants? So this is the cost per pound. I mean, this is the amount of pounds each pendant takes, right? And the cost per pound. So we want to multiply, right? So we're going to times this by 24 because that's how many pounds we are going to need altogether. Okay, so I'm actually just going to bring it up here and times it by 24, and we have 5.81. Okay, so that is the mass for all 24 of the pendants. Now, okay, so these are the pounds for all 24 pendants, and this is how much it is per pound. So we're going to multiply it, right, So we have, right, 5.814 times 3.68. Okay, so we end up taking, right, 5.814, and we multiply it times 3.68. Okay, and we get a total of 21.39, which ends up being, right, it's 21.39552. Right, and that is going to be 2140. So let's take a look at 9 and 10. A jeweler constructed a jewelry box in the shape of a rectangular prism. The box is 3 inches tall and the volume is 90 cubic inches. She wants to design a second jewelry box with the same height and volume as the first one, but in the shape of a triangular prism. What will the number of square inches in the area of the base of the new jewelry box? What will be the number of square inches in the area of the base of the new jewelry box? So we have the first jewelry box, which is the height equals 3 and the volume, right, equals 90 cubic inches. Okay, and the formula for volume of a rectangular prism is base times height. And then we have a triangular prism, which the volume formula is also base times height. Okay, and finding the volume to find B over here for our rectangular prism. Okay, is going to be, right, 90 equals, because this is our volume, right, 90 inches cubed equals, okay, our base times 3, because our height is 3, and our base equals 30. Now, for the next part, okay, we have a triangular prism with the same volume, okay, and it's going to be the same height, so equals B times H, but the H is 3, okay. Now, if it has the same volume and the same height, that means that the area of the base is also going to be the same, okay. So the area, so we have a rectangular prism. I can't draw. Let me see if I can, and we have, that has a base, right? And this base, oh, that's so bad. I don't think I could get a picture of it right now. It's much easier to draw when you're not using a mouse. I don't really know how artists are able to use a mouse, but I'll go with it. Okay, it's a rectangular prism, and the base, right, is length times width. And we know that the area, the shaded part, right, the area of this base, right, is 30, right? And the the area of the base is 10, right? So, no, 30, sorry. I saw 30 there, and this should be, there's a mistake here. This should be 90, because it has to have the same volume. Okay, so the area of the space is 30, and the volume is 90, right, inches cubed. Now we have a triangular prism. Let's see if I can do a triangular prism. Okay, and I'm going to use the actual rectangle to do it. This is making me miss Microsoft Word. I definitely don't want to use this program again because it's just too time consuming. So a rectangular prism, right? And of course this has the let's see if I can do it like that, or like that. I don't even care that there's arrows. Okay. And so we have our rectangle prism. Close enough anyway. I think I could make it better. Okay, so our base is this triangle. Okay, and we just need to know the area of it. Okay, and we know that the height, right, is going to be, of this prism, is going to be 3, and we know the volume is going to be 90. Okay, then we know that the area of this base must be 30. Even though it's a triangle, we're talking about the area of the base, because if the height is the same, right, it needs to be multiplied by the same area to get the same volume. So it is 30 square inches, the new jewelry box, the area. Okay, so a sandbox in the shape of a rectangular prism has a length of 43 inches and a width of 30 inches. Jack uses bags of sand to fill the sandbox to a depth of 9 inches. Each bag of sand has a volume of 0.5 cubic feet. What is the minimum number of bags of sand that must be purchased to fill the sandbox? Okay, so I always like to just underline the question. The minimum number of bags we're looking for of sand that must be purchased to fill the sandbox. Okay, and we know that the volume of each bag, right, of sand, volume of each bag of sand is 0.5 cubic feet. Okay. Okay. Feet cubed. we also know the dimensions of the sandbox. Just put my sandbox here. Get this out of the way. Okay, so we know that our sandbox is 43 inches in length, 30 inches wide, and a depth of 9 inches. So it is 9 inches deep. Okay, let's just get rid of this. 9 inches deep, and it's a length of 43 inches by 30 inches. Okay, and now I'm starting to see, this is inches, and the bags are in feet, right, cubed. So I need to have this also in feet cubed. Now, I can figure out the volume first in inches and then convert it to feet cubed, which is actually what I'm going to do. Okay, so I know, just erase some of this. Okay, I know that we're going to have 43 times 30 times 9 as our volume of this prism in inches cubed at the end. So let's see. I wish that I had this. I don't think this is going to work. Okay, I don't think we have apps on here, is basically what it comes down to. And no, we don't have any apps, so it's not going to work. Okay. Alright, so I'm going to use Desmos here. 43 times 30 times 9, and that equals 11,610, I believe. Okay, now we need to convert this number to cubic feet. This is cubic inches right now. Now, I'm going to do that by multiplying it. Right, I'm going to multiply it times, multiply this. I'm going to move everything over. I don't like it all the way. Okay, I'm going to multiply this times, I have 1 cubic foot, 12, every 12 inches is a foot, and I'm going to cube all of it. Okay, so I have 12 cubed. So that's 1,728 inches in every cubed foot. So 1,000, I'm just going to rewrite it, times 1 foot cubed over 1,728. Okay, inches cubed. Okay, now I'm going to get rid of inches cubed. And I'm going to divide 11, 6, 10 divided by 1728. 6.78, right? 6.71875. Okay, this is how many cubic feet, not inches, sorry, cubic feet this sandbox is. So we have cubic feet here. All right, so now we also know each bag of sand has a volume of 0.5 cubic feet. What is the minimum number of bags of sand that must be purchased to fill in the sandbox? Well, you need all of this filled in, and each bag is 0.5 of that. So we are going to divide, right? We are going to divide this number by 0.5. And this goes out, okay? So we have the numbers already there, divided by 0.5, and it's going to be, right, 13.4, which is going to make us have to get 14 bags. Okay. So a storage building is modeled below by a hemisphere on top of the cylinder. The diameter of both cylinder and hemisphere is 12 feet. The total height of the storage building is 30 feet. To the nearest cubic foot, what is the volume of the storage building? Okay, so we have to find the volume of this whole thing. So it's going to be the volume of the sphere plus the volume of the cylinder. Okay, so let me just right, the sphere, okay, volume of the sphere is it's 2 over 3 pi r cubed, okay, and then we're going to do plus, right, the volume of the cylinder, to the nearest, the total volume, okay, the volume of the cylinder, which is pi r squared times height, okay, so r, right, is half, right, because it's the same radius, so we have 2 over 3 pi, right, 6 cubed plus pi, right, that's cubed. What? Plus pi r squared times the height. Now I want to talk about the height, because this is the height of the cylinder. This is the volume of the cylinder. This is the volume of the sphere, and we're adding it together. Now the height of the cylinder ends here, okay? And we know that the cylinder, right, since it has a radius of 6, any direction you go, right, you're getting a radius. So we know that the height of the sphere, right, this amount of space is going to be 6 because it has a radius of 6. So since from here to here is 6, the rest of it is going to be 24. So instead of using h, I'm going to multiply it by 24. Wow, this is one big number. So I'm actually going to use Desmos for this. And I can. Alright, so I have 2 over 3. Actually, I'll use TI. Okay. And I'm going to pull this over, and I have I want to use alpha y equals. Okay. Enter. And I'm going to do 2 over 3. Alright. Times pi. Okay. And then we have 6. I'm going to use this button right here where the pi is. There's also this exponent button. Okay. And it's cubed. Okay. Now let me get out of this and add. Okay. And we have pi times 6 squared times 24. And our answer is 3,166.7. 3,166.7. And we want it to the nearest cubic foot, which is, 3,167. So we have 3,166.7. And then this is to the nearest foot.